A vast darkness in space defies everything we know about the cosmos. This is the Boötes Void, a region so empty and so colossal it has been called the Great Nothing. Within this apparent emptiness lie secrets that could overturn our understanding of the universe itself. You are about to discover 25 of its most profound mysteries. From the hidden forces shaping its expanse to the possibility it is a relic from before the Big Bang. Why does a place with almost no galaxies challenge our most fundamental laws of physics, and what unseen structures might be lurking within its depths? What does true emptiness mean to you? The sheer scale of this cosmic emptiness is the first and most staggering secret. The Boötes Void spans a region of space approximately 330 million light-years across. To even begin to comprehend such a distance, you must first shrink our own galaxy, the Milky Way, down to the size of a single grain of sand. Now hold that grain in your hand. The Boötes Void would not be a small empty patch around it. It would be a vast, hollow sphere larger than the biggest stadium you can possibly imagine, with that one tiny grain of sand floating in an incomprehensible ocean of nothing. This is not merely a small gap between galactic clusters. It is a colossal chasm that defies the standard model of the universe, a model that predicts matter should be distributed far more evenly. The existence of such a vast nothingness, a hole in the cosmic fabric of such magnitude, suggests our understanding of how the universe structures itself is fundamentally incomplete or perhaps even wrong. This emptiness was not always known to us. The Boötes Void was a secret the universe kept until 1981, when astronomer Robert Kirshner and his team accidentally stumbled upon it while mapping large-scale structures. At first, their findings were met with profound disbelief. How could a region of space large enough to contain tens of thousands of galaxies hold almost none? It seemed to defy not just observation but logic itself. This was not a small pocket of emptiness. It was a staggering cosmic desert on a scale that theory said should not exist. The discovery sent shockwaves through cosmology, directly challenging a foundational pillar of modern science known as the cosmological principle. This principle is a simple but powerful assumption that on the very largest scales, the universe is both uniform and looks the same in every direction. It is the idea that your location does not matter, that the cosmos is fundamentally smooth when you zoom out far enough. The Boötes Void was a glaring, monumental exception. It was a lump in the smooth cosmic batter, a hole so vast it forced scientists to confront an uncomfortable possibility. Perhaps the universe was not so even after all. This single observation became one of the most significant puzzles in modern astronomy, a ghost in the machine that demanded we either revise our principles or find a new way to explain the apparent structure of everything. This third secret strikes at the very heart of our cosmological models, revealing the Boötes Void is not just large, it is unnaturally so. The problem lies with a concept known as the statistical homogeneity scale. Think of this as the universe's maximum bubble size. Based on the standard model of cosmology, which describes the universe's composition and evolution, there is a theoretical limit to how big an empty region should be able to grow. This limit is calculated from the density fluctuations present in the early universe, the tiny seeds that eventually grew into galaxies and clusters. The mathematics predicts a ceiling, a point beyond which such profound emptiness becomes statistically impossible. The Boötes Void shatters that ceiling. Its colossal diameter of 330 million light-years is significantly larger than this predicted maximum. It is as if you found a single, perfectly still pond in the middle of a raging ocean, a pond wider than the ocean itself should ever allow. This is not a minor discrepancy, it is a fundamental contradiction. The void's existence at this scale suggests that either the initial conditions of our universe were far stranger than we thought, or the forces that guided the growth of cosmic structures are not fully accounted for in our current equations. This single anomaly, a hole of nothingness, forces us to question if the foundational rules we have written for the cosmos are truly the whole story. Yet this supposed emptiness holds a secret of its own, for the Boötes Void is not a perfect, absolute nothing. It is a place of profound scarcity, a desert with a few isolated oases. The fourth secret is the mystery of what little actually remains inside. While a typical region of space of the same immense volume would be teeming with thousands of galaxies, the Boötes Void contains only around 60. Imagine a major city built to hold millions of people, but when you arrive, you find only a few dozen solitary inhabitants living in widely separated houses. The sheer lack of galactic residents is what defines the void, but the nature of those few who do live there is equally puzzling. These are not normal galaxies. Many are isolated, peculiar, and often irregular in shape, having evolved in profound solitude, cut off from the frequent galactic interactions and mergers that shape most others. They are the cosmic equivalent of hermits, having developed under conditions so rare we barely understand them. Their existence does not solve the mystery of the void, it deepens it. Why did these specific galaxies form here, in this vast cosmic desert, when all around them is nothing? Their lonely presence suggests that the forces at work in the void are not merely about the absence of matter, but about a strange and selective process that allowed only a handful of structures to coalesce against all odds. But the influence of this great nothingness may extend far beyond its own dark borders. The fifth secret proposes that the Boötes Void is not just an empty space, but a supervoid, a region of such profound underdensity that it actively warps the very fabric of the cosmos around it. To understand how, you must first picture the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space. This ancient light is the universe's baby picture, and it is remarkably uniform. Yet when scientists map its temperature, they find mysterious cold spots, regions slightly chillier than the average. One of the most famous and puzzling of these is known simply as the CMB cold spot. The question is, could our void be the cause? The link is a phenomenon called the integrated Sachs-Wolf effect. Imagine a photon, a particle of light from that ancient afterglow, traveling for billions of years to reach our telescopes. If its journey takes it through a region of space that is still gravitationally evolving, like a supervoid, something strange happens. As the photon enters the void, it must climb out of the gravitational well of the denser space around it. This uses up some of its energy. Then, as the universe expands and the void itself grows deeper, the gravitational potential the photon climbs out of is actually weaker than when it entered. The photon, in a sense, does not get all its energy back. The net result is that the light loses a tiny amount of energy, and since lower energy light appears cooler, it registers as a cold spot in the cosmic microwave background. So, if the Boötes Void is indeed a supervoid, its immense gravitational footprint could be imprinted on the sky as one of these cosmic cold spots. The staggering possibility is that this vast emptiness is not just a passive hole, but an active sculptor, its gravitational shadow reaching across the universe to leave a permanent, chilly mark on the first light of creation. This coordinated motion points to a force that should not exist. Astronomers have observed something they call dark flow, a mysterious and controversial drift in the motions of entire galaxy clusters. These colossal structures are not just moving apart with the expansion of the universe, they are streaming together in a specific, coherent direction, as if being pulled by something immense. The problem is, there is nothing in the observable universe large enough or powerful enough to exert such a gravitational tug. The source of this pull must lie beyond the edge of everything we can see. This is where the Boötes Void enters the picture in a truly mind-bending way. Could this vast emptiness be a clue, a signpost pointing toward that unseen source? One radical theory suggests that the void itself, or rather the unimaginable event that carved it out, was the work of a gravitational titan from a realm outside our own. Picture our observable universe as a single bubble in a much larger cosmic foam. The gravitational pull from a neighboring bubble universe, one of a scale we cannot comprehend, could have tugged on the fabric of our own cosmos in its earliest moments. This titanic interaction might have literally ripped matter away, creating the Boötes Void as a scar, a permanent dent in our reality. The same lingering gravitational influence from that unseen beyond could now be the very force driving the dark flow, pulling countless galaxies on a secret journey toward a horizon we cannot even see. The great nothingness of the void might not be an end, but a window into the infinite something that lies past the edge of our knowledge. This colossal emptiness may be a fossil, a ghost from the very first instant of time. To understand its secret origins, we must journey back to the epoch of cosmic inflation, a period of unimaginably rapid expansion that occurred a fraction of a second after the Big Bang. In this fleeting moment, the entire universe we know ballooned from smaller than a proton to a staggering size, all in an eye blink, and within that violent, exponential growth, the seeds for all future structure were sown. Here on the quantum scale, empty space was not truly empty. It was a seething foam of virtual particles constantly flickering in and out of existence. These are known as quantum fluctuations, tiny, temporary ripples in energy. During inflation, something remarkable happened to these ripples. The fabric of space itself stretched at a speed faster than light, and as it did, it stretched those tiny quantum ripples along with it. Imagine drawing a tiny, wiggly line on the surface of a balloon, then inflating that balloon to the size of a city. That tiny, subatomic wiggle would be stretched into a vast, cosmic-scale wave. This is precisely what is thought to have created the first variations in the density of the universe, the gravitational seeds that would later grow into galaxies and clusters. But what if, in some regions, the fluctuation was not a slight overdensity, but a slight underdensity? What if the quantum ripple was a tiny pocket of nothingness? Inflation would have stretched that tiny void as well, magnifying it to an astronomical scale. The Boötes Void could be one of these primordial relics, a bubble of underdensity inflated to a size of 330 million light-years. It would not be a structure that formed later, but a fossilized imprint of the universe's quantum origins, a scar from its most violent growth spurt. This means the great nothing we observe today is not an absence, but a direct message from the first moments of everything, a whisper from the dawn of time frozen in the vastness of space. But the void is not a static monument, it is a living, evolving entity. Its eighth secret ties it to the most mysterious force in the cosmos, dark energy. We now know the universe's expansion is not slowing down, it is accelerating, driven by an unknown repulsive force we call dark energy. This force does not just push galaxies apart, it actively stretches the very fabric of space between them. Now consider the Boötes Void, a region already defined by its profound emptiness. In a universe filled with matter, gravity acts as a counterbalance, pulling things together and resisting the stretch of dark energy. But inside the void, there is almost no matter to provide this gravitational counterweight. It is a place where dark energy meets almost no resistance. This means the void is not merely existing, it is being actively inflated from within, stretched and made even emptier by the dominant force of our universe. The void is a dark energy amplifier. Studying how it grows and evolves over cosmic time could give us a pure, unadulterated measurement of dark energy's strength and behavior, something nearly impossible to do in the crowded, gravitationally messy regions of space. The great nothingness becomes a pristine laboratory, a cosmic vacuum chamber where we can observe the universe's most dominant and most elusive component at work. The profound emptiness of the void may offer a glimpse into the deepest fracture in modern physics. For decades, scientists have struggled to reconcile two monumental theories that describe our universe. On one hand, we have Einstein's theory of general relativity, which masterfully explains the behavior of gravity and the large-scale structure of spacetime, from orbiting planets to the bending of light around galaxies. On the other, we have quantum mechanics, the wildly successful rules governing the strange, probabilistic world of atoms and subatomic particles. The problem is, these two pillars of physics are fundamentally incompatible. They speak different mathematical languages and break down under extreme conditions, like those found inside a black hole or at the very beginning of the Big Bang. Unifying them into a single theory of quantum gravity is perhaps the greatest unsolved problem in all of science. This is where the Boötes Void, in its ultimate isolation, becomes more than just empty space. It transforms into a unique natural laboratory. In our local, matter-rich universe, the delicate effects of quantum gravity are utterly drowned out by the powerful roar of conventional gravity from stars, galaxies, and dark matter. The signal is too weak to detect, but inside the void, that roar becomes a whisper. With so little matter to create gravitational noise, the subtle, quantum-scale ripples in the fabric of spacetime itself might, in theory, become detectable. It is like trying to hear a pin drop in a crowded, noisy stadium versus in a silent, empty hall. The void is that silent hall. The near-perfect vacuum of this region could allow for the magnification of phenomena where gravity and quantum mechanics meet. One such idea involves the concept of vacuum decay. What if our universe is not in its most stable state? What if the vacuum of space possesses a certain energy, and there is a lower, more stable energy level it could drop into? This shift would propagate at the speed of light, rewriting the fundamental laws of physics in its wake. While this sounds like science fiction, the conditions of a supervoid, with its bizarrely low energy density, could be the most likely place for such a rare quantum event to spontaneously trigger. By observing the void, we are not just looking at nothing. We are watching for the faintest tremor in nothingness, a sign that the vacuum itself is shifting, which would be a direct observation of quantum gravity in action. The great nothingness thus holds the key to perhaps the greatest something, a unified theory of everything. The very geometry of the Boötes Void holds its own strange secret. We often picture it as a perfect dark sphere, a single bubble of nothing adrift in the cosmos, but detailed three-dimensional maps reveal a far more complex and irregular reality. Its borders are not smooth, they are ragged and defined by faint, wispy filaments of galaxies, like tendrils of smoke clinging to the edge of a colossal cave. This is not the simple, round hole we might imagine. Its chaotic morphology is a direct challenge to any straightforward story of its birth. A single, clean event of inflation might have left a more spherical imprint. This tangled, lumpy shape suggests a history written in violence and slow, cosmic consumption. One compelling theory is that the Boötes Void is not a single entity at all, but a monstrous amalgamation. Over billions of years, smaller, individual voids may have gravitated toward one another, their walls of galaxies colliding and merging, their empty interiors fusing into one ever-growing supervoid. Think of soap bubbles on the surface of water, slowly drifting together until their thin membranes meet and pop, merging into a single, larger and irregularly shaped bubble. This process would have been a slow, gravitational dance spanning eons, gradually sculpting the messy, filament-lined structure we detect today. Each of those faint galactic threads on its border could be a ghostly remnant of a smaller void's edge, a fossilized wall from a long-forgotten merger. This means the great nothingness is not a static monument, but a dynamic structure that has been growing and evolving, consuming its neighbors to become the titanic emptiness we observe now. Its shape is not a simple fact, but a complex historical record, a map of a past filled with silent, catastrophic collisions in the dark. The universe seems to be hiding its own ordinary matter. Astronomers have tallied up all the protons and neutrons, the stuff that makes up stars, planets, and you, only to discover a staggering fact. Nearly half of it is simply missing. This is the cosmic missing baryon problem, a profound accounting error on the grandest scale. The Boötes Void holds a compelling clue to this mystery. What if this great emptiness is not truly empty of matter, but is instead filled with a form of it so elusive we have barely been able to detect it? The secret may be a sea of incredibly diffuse million-degree gas. This is not a cold, dark vacuum, but a vast, thin, and searingly hot plasma, so spread out that a single cubic meter of it might contain only a few particles. To our optical and radio telescopes, this wispy gas is completely invisible, a ghost in the machine, but its presence can be betrayed by the very light that journeys through it. When the ancient light from distant quasars, brilliant beacons from the early universe, travels for billions of years and passes through the void, this superheated gas leaves a faint fingerprint. It subtly scatters the light, absorbing specific high-energy wavelengths and imprinting a signature known as the Sunyaev-Zeldovich effect. It is like trying to see a faint, heat-hazed mirage in a vast desert. The void, long considered a place of absence, could in fact be one of the universe's great reservoirs, hiding a significant portion of its missing ordinary matter in plain sight, not as galaxies, but as a silent, shimmering ocean of primordial heat. The galaxies are missing, but the gravity might not be. This leads us to a profound possibility hidden within the void's emptiness. While the brilliant, shining matter of stars and planets is almost entirely absent, the invisible scaffolding of the cosmos could remain. The Boötes Void might be a vast reservoir of dark matter. Think of the universe's structure as a city. The glowing galaxies are the buildings, the lights we can easily see. Dark matter is the underlying foundation, the ground and the rock upon which everything is built. In most of the universe, the lights and the foundation are jumbled together, making it impossible to study the foundation on its own. But in the Boötes Void, the lights have been turned off, the buildings are gone. This allows us for the first time to potentially study the pure foundation, the dark matter, in isolation. We could be looking at a smooth, colossal halo of this mysterious substance, a ghostly sphere that perfectly outlines the great nothingness. How could we ever detect something so invisible? The answer lies in a cosmic phenomenon called gravitational lensing. The immense gravity of any mass, even the invisible mass of dark matter, bends the path of light traveling past it. It acts like a lens made of pure gravity. If a dense halo of dark matter surrounds the void, then the light from galaxies located far behind it on the other side of this cosmic desert would have to travel through this invisible lens. As it does, its path would be subtly warped, its image slightly distorted. By meticulously mapping the shapes of millions of distant galaxies seen around the edges of the void, astronomers could trace the invisible gravitational field, painting a picture of the dark matter halo's shape and density. The void, therefore, becomes a unique laboratory. It offers a clean experiment free from the interference of normal matter to answer fundamental questions. Is dark matter smoothly distributed, or does it clump in ways we do not expect? Does it interact with itself, or simply pass through itself like a ghost? The silence of the Boötes Void might be the perfect place to finally listen for the whispers of the universe's most dominant, yet most secretive component. Within the profound quiet of the Boötes Void, the few galaxies that exist are living a life of cosmic solitude. These are the void galaxies, and their isolated existence holds a secret key to understanding galactic evolution itself. Far from the dense, bustling galactic cities found in clusters, these stellar islands have grown up in the ultimate cosmic countryside. In a typical cluster, galaxies are in constant motion, frequently brushing past one another, gravitationally tugging at each other's spiral arms, and sometimes colliding in spectacular mergers that trigger bursts of new star formation. It is a chaotic, vibrant metropolis, but inside the void, a galaxy can live for billions of years without ever encountering a neighbor. This profound isolation has profound consequences. Without the gravitational harassment and gas-stripping effects of nearby galaxies, void galaxies are thought to be quieter, more stable, and significantly older. They are like ancient, undisturbed libraries, preserving a record of what galaxies were like in the distant past before the era of frequent cosmic collisions. Their star formation is not sparked by violent interactions, but is a slow, internal process, a quiet burning that may have continued almost unchanged for eons. This makes them pristine laboratories. By studying these cosmic hermits, we are not seeing the flashy, modern galaxies shaped by a life in the fast lane. We are looking at relics, galactic fossils that show us how a galaxy evolves when it is left entirely to its own devices, offering a pure, unadulterated view of stellar life in the deepest quiet of the universe. This immense cosmic desert has become a proving ground for our deepest theories of the universe. The Boötes Void is a secret battleground where alternative models of cosmology are forced to confront a reality they struggle to explain. For the reigning standard model, the void is a challenging outlier. For competing theories, it is often a fatal flaw. Take, for example, a concept known as modified Newtonian dynamics, or MND. This theory proposes that we do not need dark matter to explain the motions of galaxies. Instead, it suggests that gravity behaves differently at very low accelerations, the kind found in the outskirts of galaxies. MND has had some success explaining individual galaxy rotations, but it faces a monumental test with the Boötes Void. The problem is one of formation. In a MND-dominated universe, the immense underdensity of the void should have been smoothed out by the enhanced effects of gravity over vast distances. The theory struggles to create or even permit such a colossal and stable region of nothingness. The void's sheer size and persistence become a powerful argument against MND, suggesting that an invisible, gravitational scaffolding like dark matter is indeed necessary to create and maintain such a structure. Another challenger is the tired light hypothesis, an alternative explanation for the redshift of distant galaxies. Instead of attributing the redshift to the expansion of the universe, tired light suggests that photons simply lose energy over immense distances, like a marathon runner slowing down. This would mean the universe is not expanding at all. Yet, the Boötes Void delivers a devastating blow to this idea. If the universe is static and not expanding, then such a vast, empty region would have no reason to exist, and its gravitational influence on the cosmic microwave background, which we see as a cold spot, would be impossible to explain. The void's very existence and its dynamic role in the cosmos relies on a universe that is evolving and stretching over time. For every alternative theory that seeks to dethrone the standard model, the Boötes Void stands as a silent, immovable referee. Its profound emptiness is not just a curiosity. It is a critical piece of evidence, a reality check that separates elegant ideas from those that can truly account for the deepest, darkest mysteries of our cosmos. Its location in our sky is a secret in itself. We find the Boötes Void in the constellation of Boötes, the herdsman, a region of the northern sky that appears deceptively ordinary to our eyes. But its cosmic address is far more telling than its simple placement on a star chart. This great nothingness is not a nearby shadow. It resides a staggering 700 million light-years away from our own Milky Way galaxy. This immense distance is not just a number, it is a time machine. The light that finally reaches our telescopes today, the faint photons from the handful of galaxies on its edge, began its journey 700 million years ago. We are not seeing the void as it is now, but as it was in a distant cosmic past when the first complex life was just beginning to stir in Earth's oceans. This time lag adds a profound and unsettling layer to the mystery. We are studying a fossil in real time, a snapshot of an ancient structure whose present reality is completely unknown to us. What has happened in that void over the last 700 million years? With the relentless acceleration of dark energy, the most likely scenario is that it has grown even larger and even emptier. The few galactic oases within it may have been pushed even further apart, their stars burning in an ever-deepening sea of darkness. It is equally possible that some slow, cosmic process has begun to refill it, with faint streams of gas finally collapsing to form new, lonely islands of stars. We simply do not know. The Boötes Void we map is an echo, a ghost image from an era so remote that its current state is one of the greatest unknowns. We are left to wonder if we are observing a structure in its middle age, or if we are watching the final, silent act of a cosmic drama that has already reached its conclusion. These isolated galaxies are not just quiet and old, they are profoundly strange. Each one is a cosmic rebel, having evolved under rules that simply do not apply anywhere else. Far from the bustling galactic cities, these void galaxies have become hoarders. They are often incredibly rich in pristine hydrogen gas, the raw fuel for star formation. In crowded galactic clusters, this gas is constantly stripped away by gravitational interactions or heated to extremes, shutting down star birth. But here, in the deep quiet, these galaxies have held onto their primordial fuel reserves for billions of years. This abundance of gas leads to another key peculiarity, a trait known as low metallicity. In astronomy, metals are any element heavier than hydrogen or helium. These heavier elements are forged in the nuclear furnaces of stars and scattered across space by supernova explosions. In a typical galaxy, this recycled material gets incorporated into new generations of stars, enriching them. But in the void, with so few neighbors, there have been far fewer supernova to pollute the environment. The gas here is purer, more primitive. When new stars do form within these void galaxies, they are made from this ancient, unenriched material. This means the stars are often bluer, hotter, and significantly poorer in heavy elements compared to stars like our own Sun. They are a closer match to the very first stars that ignited in the early universe. This makes each void galaxy a living fossil, a cosmic time capsule preserving conditions that have largely vanished from the rest of the universe. Their slow, gas-rich, and metal-poor existence offers us a direct glimpse into a much more primordial era of cosmic history, all held in suspension within the great nothing. Perhaps the most staggering secret of the Boötes Void is that it may not be a feature of our universe at all, but a scar from a collision with another. This idea emerges from one of the most profound theories in modern cosmology, known as eternal inflation. It suggests that the Big Bang was not a unique, singular event, but a local phenomenon within a much grander, possibly infinite meta-universe. In this picture, our entire cosmos is just one expanding bubble of spacetime, floating in a frothing, eternally inflating sea. Countless other bubble universes could be popping into existence all the time, each with its own unique laws of physics. Now imagine two of these bubbles drifting through the multiverse on a slow-motion collision course. When they finally meet, they would not annihilate each other like physical objects. Instead, their boundaries, the very fabric of their spacetime, would interact. This cosmic contact would be a cataclysm of unimaginable scale, releasing immense energy and fundamentally altering the structure of both universes at the point of impact. According to this theory, such a collision would not create a mountain of new matter, but rather it could rip matter away. It would leave behind a vast, empty, and stable region, a cosmic bruise where the laws of our universe were forever changed by the touch of another. The Boötes Void, with its inexplicable scale and profound emptiness, fits the description of such a scar perfectly. It could be the fingerprint of a neighboring cosmos, a permanent dent in our reality, left by a long-ago encounter with a universe that operates by rules we cannot even comprehend. This means the great nothingness we observe might be the most direct evidence we will ever have that our universe is not alone, that we are just one island in an infinite archipelago of realities. Deep within the cosmic silence of the Boötes Void, there may be a frozen echo from the universe's first and only sound. This is the secret of baryon acoustic oscillations, a ghostly pattern imprinted on the cosmos when it was a seething hot plasma, just 380,000 years old. In that primordial era, the universe was a dense, churning fluid. Gravity tried to pull matter together into clumps, while the immense pressure of radiation fought to push it apart. This created a tug of war, a series of powerful pressure waves that rippled outward through the plasma, much like sound waves moving through air. These were literal sound waves crossing the infant cosmos. Then, in a flash, the universe cooled enough for atoms to form, suddenly becoming transparent. This moment, the release of the cosmic microwave background, effectively froze these waves in place. The ripples stopped dead in their tracks, leaving a permanent, spherical imprint in the distribution of matter. This imprint gives the universe a preferred scale, a standard ruler. We see its signature today in how galaxies are spaced. They are slightly more likely to be found at a specific distance from each other, a distance that corresponds to the radius of those frozen sound bubbles. It is the universe's cosmic rhythm, a drumbeat from creation etched into the sky. So, where does the Boötes Void fit into this rhythm? Its colossal size is eerily close to the scale of these baryon acoustic oscillations. One compelling idea is that the void is not an outlier, but a direct consequence of this ancient music. It could be a single, vast trough in that frozen wave, a region where, by the random chance of the initial fluctuation, the wave of matter pulled away, leaving a spherical region of profound underdensity. In this view, the void is not a mistake in the cosmic pattern, but the pattern itself writ large, a single, resonant note of silence held for billions of years. Yet there is a problem. The void's diameter is so immense that it pushes at the very upper limit of what these oscillations should allow. It is as if one single beat of a drum was somehow louder and longer than all the others. This forces a question. Is the Boötes Void a perfect example of the baryon acoustic oscillation scale, confirming our models of the early universe? Or is its exaggerated size a clue that something else, something beyond those initial sound waves, played a role in its creation? The void's emptiness might be the key to listening more closely to the universe's first and deepest note. The profound silence of the void might be its most valuable resource. While we search for signs of intelligence among the stars, the most advanced civilizations could have already departed for the cosmic countryside. A truly advanced society, one classified as a Type 3 on the Kardashev scale, would have harnessed the total energy output of its entire galaxy. But what comes next when even a galaxy's resources begin to feel constrained? The next logical step would be to seek out the largest possible real estate, far from the gravitational turmoil and intense radiation of galactic clusters. The Boötes Void, with its unimaginable volume and calm stability, would be the ultimate destination. Think of our current galaxy as a bustling, densely packed metropolis. It is vibrant but also dangerous, filled with supernova explosions, gamma-ray bursts, and the constant gravitational jostling of neighboring stars. For a civilization capable of engineering on a cosmic scale, this environment would be chaotic and limiting. The void, by contrast, is an endless, quiet plain. Here, a Type 3 civilization could construct structures we can barely conceive of, perhaps building a Dyson sphere not around a single star, but around the entire void itself, using the collected energy of every star on its distant borders. They might use the empty space to conduct physics experiments of unimaginable scale, or even manipulate the fabric of spacetime itself, projects that would be impossible in the crowded, noisy galactic core. The very emptiness that makes the void a desert to us could make it a paradise for an intelligence that has transcended its biological origins. The great nothingness may not be empty at all, but a future engineering site, silently being prepared for a purpose we are not yet advanced enough to comprehend. This great emptiness is a lens made of nothingness. While we think of gravity as a force that pulls, its true nature, as Einstein revealed, is the warping of spacetime itself. Any mass from a planet to a galaxy creates a dip in this cosmic fabric, and light follows these curves. A massive object acts like a magnifying glass, bending and focusing light from objects behind it. But the Boötes Void presents a bizarre opposite effect. Its immense volume of near-nothingness creates a vast, shallow gravitational hill. Instead of pulling light inward, this hill causes light rays to subtly spread apart as they pass through. Think of it as a colossal, cosmic diverging lens. If a standard gravitational lens is a magnifying glass that concentrates light, the Void's lens is like the concave side of a spoon, causing the image to stretch and distort outward. The galaxies we see lying directly behind the Void do not appear brighter or more focused. Instead, their shapes are minutely stretched into faint, elongated arcs, their light subtly pushed away from the Void's center. This phenomenon, known as weak gravitational lensing, is incredibly faint, a distortion so slight it is only detectable by analyzing the shapes of millions of background galaxies. Yet this tiny signal is profoundly powerful. It allows us to literally weigh the Void. By measuring how much the light is bent, astronomers can calculate the total mass responsible for the bending. This includes not just the handful of visible galaxies, but everything, most importantly, the vast, invisible halo of dark matter that we suspect outlines this emptiness. The Void's own gravitational shadow, its subtle warping of the light of distant worlds, becomes the most precise scale we have to measure the mass of nothing itself. This cosmic desert is not the only one of its kind. To understand its true secret, you must see the universe not as a uniform scatter of stars, but as a vast three-dimensional web. This is the cosmic web, the largest structure we know, a labyrinth of brilliant galactic filaments intersecting at dense clusters, all wrapped around immense, interconnected voids. In this grand architecture, empty space is not the exception, it is the rule. Voids make up most of the volume of the observable universe. They are the empty rooms in the cosmic mansion. The Coma Void, the local void that our own Milky Way is drifting along the edge of, and dozens of others pepper the darkness. So if voids are common, what makes Boötes so special? Its secret is not its existence, but its staggering scale. While most cosmic voids span 100 million light-years or so, the Boötes Void is more than 3 times that size. It is the king of emptiness, a supervoid so colossal it stands apart even from its peers. Think of it like islands on a planet. Most are small, like the Canary Islands or the Hawaiian chain. But then there is Greenland, a single island so massive it defies the typical category. Boötes is the Greenland of the cosmos, an outlier so extreme that it challenges the statistical models of how the cosmic web should form. Other large voids exist, like the recently mapped KBC Void, but none match the sheer, jaw-dropping volume of the Great Nothing. Its rarity is the key to its mystery. In a universe governed by predictable rules and random chance, finding something this immense is like rolling a die and getting a million sixes in a row. It is not impossible, but it is so wildly improbable that it forces us to ask if the dice were loaded, if some unknown process in the early universe conspired to create a void of such magnificent proportions. The silence of the Boötes Void echoes not just through space, but through our own stories. This real cosmic mystery has become a fertile ground for science fiction, transforming from a scientific curiosity into a canvas for our deepest hopes and fears. Writers and creators have looked into that great nothing and seen more than just empty space. They have imagined it as the ultimate hiding place, a perfect location for inconceivable alien megastructures or the hidden fortresses of ancient, godlike civilizations. What better place to conceal a universe-altering engine or a gateway to another dimension than in a void so vast that no one would ever think to look? Yet more often, the void serves a darker purpose. It taps directly into the primal human fear of emptiness and isolation. The concept of a true nothingness, a place where the rules of reality might break down, is a powerful engine for cosmic horror. It is not about the monster you can see, but the terrifying possibility of being utterly alone in an infinite, uncaring cosmos, or worse, encountering something that should not exist in such a void. This cultural resonance reveals a profound secret. The Boötes Void is more than a collection of scientific data. It has become a modern myth, a symbol for the unknown that challenges not just our physics, but our very place in the grand story of existence. This profound darkness pushes our greatest instruments to their absolute limits. Peering into the Boötes Void is not like looking at a nearby galaxy, bright and full of detail. It is an exercise in searching for the faintest embers in an ocean of black ink. The primary challenge is its sheer scale and the incredible faintness of the few galaxies that call it home. These are not brilliant spirals, but often dim, irregular collections of stars, drifting at distances of hundreds of millions of light years. Their light is so feeble that capturing it requires both an impossibly wide field of view to cover the void's colossal volume and an exquisitely sensitive eye to detect its ghostly whisper. For decades, our telescopes could only see the very brightest of these isolated galaxies, leaving the true population and finer structure of the void shrouded in mystery. It was like trying to map an entire continent at night with nothing but a single, narrow beam flashlight. This technological barrier has been the final lock on the void's deepest secrets, a blind spot imposed by our own limitations. But that lock is now being broken. A new generation of observatories is turning its gaze toward the great nothing, equipped with vision that transcends human ability. The James Webb Space Telescope, with its massive golden mirror and infrared eyes, can peer through cosmic dust and see the faint, redshifted glow of the void's most ancient stellar systems. It is reading the light of galaxies previously lost to the darkness. Meanwhile, back on Earth, the Vera C. Rubin Observatory is preparing to undertake a mission of unprecedented scope. Its massive camera will scan the entire southern sky every few nights, not once, but over and over for a decade. This relentless survey will not just find a few more faint smudges in the void. It will map the precise positions and shapes of billions of galaxies, allowing us to see, for the first time, the void's true three-dimensional structure and the subtle gravitational warping it imposes on the space around it. These instruments are not merely better telescopes, they are keys designed for a specific lock, finally giving us the power to see the invisible and measure the immeasurable. The darkness of the Boötes Void is about to give up its ghosts, revealing a hidden universe we have only been able to imagine. The Boötes Void forces us to ask a question so fundamental we rarely give it a second thought. What is nothing? In our daily lives, we think of an empty room or a blank page as nothing. But these are just absences of things within a space that is still filled with air, light, and possibility. The void offers a far more radical definition of emptiness, a region of space where even the background hum of the cosmos is dialed down to an almost imperceptible whisper. This is not a passive absence, but an active quality of the universe. The great nothingness challenges the very idea that space is merely a backdrop for matter. It suggests that emptiness itself is a substance, a feature of reality with its own properties and behaviors. We are forced to confront the unsettling truth that nothing is not simply the lack of something. It is something in its own right. This philosophical shift is as profound as any astronomical discovery. If we define the universe by what exists, by its galaxies and stars, then the void is a baffling error. But if we consider that emptiness is a foundational component of the cosmos, as integral to its structure as the glittering filaments of the cosmic web, then the Boötes Void is not a hole. It is a cornerstone. It becomes one of the universe's primary ingredients, a vast and necessary silence between the notes of creation. This perspective transforms the void from a cosmic anomaly into a cosmic essential, a part of the universe's deep grammar we are only just beginning to understand. This nothingness is not inert. Modern physics tells us that a perfect vacuum, a true and total nothing, does not exist. Even in the deepest, darkest reaches of the void, space is not truly empty. It is a seething, bubbling foam of quantum potential. Virtual particles flicker in and out of existence, borrowing energy from the fabric of space itself before vanishing back into the void. Fundamental fields, the underlying structures that give rise to particles and forces, permeate every cubic centimeter of this apparent emptiness. The void, then, is not an empty box. It is a box that appears empty to our crude instruments, but is in fact filled with the most fundamental activity of reality. The Boötes Void is so quiet that it might be the best place in the entire universe to finally listen for the faint hum of these quantum fields, to observe nothing itself in its purest, most dynamic state. The ultimate secret the void holds is not about what is missing, but about what is always there, hidden in plain sight. This forces a final, humbling realization about our own place in the cosmos. We live in a vibrant, matter-rich neighborhood, a bustling galactic suburb. From our vantage point, we have built our physics and our philosophy on a reality defined by presence. The Boötes Void is a stark reminder that our experience is not the universal rule. Most of the cosmos is not like our home. It is dark, quiet, and profoundly empty. Our bright, noisy corner of the universe may be the true anomaly. The void teaches us that we are not the center of the universe in any sense, that we exist in a rare and precious oasis of matter and light, surrounded by an infinite, silent ocean of nothing. This great emptiness is the true face of the cosmos, and in its dark mirror we see our own existence for what it is, a fleeting and brilliant spark in an endless, quiet night. So we arrive at the final and most profound secret of the Boötes Void, a question that has been echoing through every discovery and every failed explanation. Is this great nothingness simply a cosmic error, a one-in-a-trillion statistical fluke that our models will eventually account for with more data and finer tuning? Or is it the single biggest clue we possess, a glaring signpost pointing toward a truth so profound it demands a fundamental rewrite of our understanding of the cosmos? This is the ultimate choice the void presents to us. If it is a mere fluke, then its existence is a monument to random chance, a universe-sized roll of the dice that came up empty on a scale we find baffling but not impossible. Our current laws of physics, with enough adjustments and caveats, could eventually stretch to contain it. We would simply have to accept that we live in a universe capable of producing such a magnificent anomaly. But if it is a clue, then everything changes. Its impossible size, its gravitational shadow, its primordial galaxies, and its eerie silence are not puzzles to be solved within our current framework. They are screams from the data telling us our framework is broken. It could be the first hard evidence for a multiverse, a scar from a cosmic collision. It could be the clearest signal of modified gravity or a new type of dark energy. It might even be a window into the quantum nature of spacetime itself. The Boötes Void does not give us answers, it presents us with a choice. Do we cling to the cosmology we have built, patiently working to fit this colossal square peg into a round hole? Or do we take this great nothingness at its word and accept its silent, dark challenge to start building a new cosmology from the void outward? The universe has drawn a circle of nothing 330 million light-years wide and left it for us to find. What we write inside that circle will define the future of our quest to understand everything. The journey through these 25 secrets reveals a truth far stranger than fiction. The Boötes Void is not a mere empty space. It is a cosmic key, a single anomaly with the power to unlock entirely new chapters in physics and cosmology. From challenging the cosmological principle to whispering secrets of quantum gravity, From hiding missing matter to possibly bearing the scar of a multiverse collision, this great nothingness has consistently defied our expectations. It teaches us that emptiness is not passive, but a dynamic and fundamental component of the universe. Each mystery we have explored, from its impossible scale to its lonely galaxies, points toward a deeper reality we are only beginning to grasp. This void forces us to question everything we think we know, pushing the boundaries of science and imagination. So the next time you find yourself under a clear night sky, look up toward the constellation of Boötes the herdsman. Know that within that patch of seemingly ordinary darkness lies one of the universe's most profound puzzles, a colossal sphere of apparent nothingness that holds the potential to rewrite our story of everything. What do you think the ultimate secret of the Boötes Void truly is? Share your own thoughts and theories in the comments below. The greatest discoveries often begin not with what we see, but with what we dare to question in the dark.